have our determinant, but we also saw the shortcut for figuring out the determinant of a 3 by 3 where you rewrote the first and second column. The green diagonals would all be added up. Do the red diagonals separately, add those up, and then subtract them from the green ones. So you would get whatever sum of the green arrows would be, and then you would subtract whatever the sum was of the red arrows. That would give you your determinant. If your determinant is not a 0, that means you can find an inverse of a square matrix. So we can now solve systems of equations with 3 by 3s. We can now find inverses of 3 by 3s, but to start off, see if you can find the determinant of this one. Rewrite those first two columns and add things up. Usually I like to use orange boxes, but this time I used white clear boxes, which are very hard to see, so I gave myself hints of where to click. See if it works. There's your arrows in one direction. There's your arrows in the other direction. Add them both up. And we have a determinant of negative 45. So because this has a determinant, the inverse exists. But for 3 by 3s, this will always be on a calculator part of your test, where you now can use your calculator. You would enter this matrix into your calculator and use the inverse button on your calculator. So it's that easy with 3 by 3s. So here, given this matrix P, determine the value of x for which the inverse doesn't exist. So again, we do our arrows in one direction. We would do our arrows in the other direction. See if I have hidden things here. Oh, I do. There they are. So our determinant would be our red arrows. That will get subtracted. Our blue arrows would get added. Did I do anything else? Oh, I did. And if it's equal to 0, then the inverse won't exist. Well, the number is one that if you tried to guess and check values of x, I don't think you'd get that very quickly at negative 14 over 3. Is that too quick? Everybody good? Awesome. So I'd like you to type in A and B into your calculator. So take some time, put A into your calculator, put B into your calculator, and then use your calculator to find A. So I will do this as well. So you go second matrix, Go over to edit. A is now a 3 by 3. I put in matrix A. Always good after you typed it in to double check it. Same thing for matrix B.
Come see me. Where's Leila?
There is blood donor and elementary tree. What are you looking for?
Leila. I'm also looking for
Maybe it's also
there's one other one.
Teresa's not. There's also a lot of people going in this class that you will find here. All right. Okay, we've got our things set into our calculator. We can now go second matrix A. And once you've got matrix A in there, at the matrix button, it's X inverse. You can just hit inverse. And I'll come up with a lot of decimals. You can hit math, fraction, and change them all back to nice numbers. Now part B says, can you find something that if you multiply A times P, it equals B? This would take forever if you put variables and tried to do it by hand. You could do A, B, C, and do a whole bunch of, you would get a whole bunch of systems of equations, 9 of them, which you would have to try to see if you could figure out how you would solve them. Possible, but not very enjoyable. So what we can do is we can set up the equation, A times P is equal to B. Now, if you multiply by an inverse, you get the identity matrix, which is 1. So if I multiply A by A inverse, that will get rid of the A and the A inverse, just leaving you with the identity matrix, which is 1, which would just leave you with P. Order matters. So if the A is out in front, then I have to multiply the A inverse in the front, which means I also have to multiply the A inverse in the front on the other side. And now I can just go to my calculator and say, this is my A inverse. I want to take that answer and multiply it by matrix B. And I get an answer for P. Which means with this on your calculator, we can now solve systems of equations with matrices. So for part A, what we would do is we would take and set up a coefficients matrix. Somewhere in there. 1, 2, 3, those are my coefficients. Then I would set up my variables matrix and my answers matrix. I would label My coefficients matrix is matrix A. My variable matrix is matrix X. And my answer is matrix as matrix B. So I can write it a lot shorter by just saying A times X is equal to B. And then you would put both A and B into your calculator. If you wanted to get X by itself, you would have to multiply the fronts of both sides by A inverse. Type that into your calculator, and there's your X, your Y, and your Z. So, by hand, we did the 2 by 2 with the inverse by hand. And everybody agreed that still substitution and elimination was better. But with the 3 by 3, and if you are allowed to use your calculator, this is a lot quicker than substitution and elimination. Problem? It requires your calculator. Good thing? A lot of things require technology these days. And if you can use technology, right, to find something out, it can be a lot quicker. I don't know the capital of Mexico. I can just ask Alexa, and they'll tell me right away. It's a lot quicker than walking to Mexico, asking someone there, what's the capital? First having to learn Spanish, of course, so that I can communicate when I get there. And then coming back and being like, oh, that was a good use of time. So one of the things that we are always looking at in our life is, how do we do things fastest, but still accurate? Because that's helpful for any business. You can do things faster, but still accurate and right. You would choose that over doing something slow. And if you can do it faster, you might save yourself money, and then that eventually makes you more money. So in a business model, there's always this idea of efficiency. So in this case, if we can use our calculator, this is very efficient. Probably, I don't know. If you tried to say that into Alexa, Alexa, please solve the following system of equations. I have 2x plus 2y plus 3z equals 3, x minus y plus z equals 2, 2x plus y plus z equals 8. What are x, y, and z? I think Alexa might not like that. Here's what I found on the web. That's not helpful. Then they ask you, was that helpful? You feel bad saying no. So you could do, I'll leave part B. You could do part B in the same way.